Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. In the last couple of videos, we saw how to approximate binomial distribution using Poisson distribution. We saw conditions for the same. We did certain examples also on the same. In Stats 1, you might have also studied how to approximate binomial distribution using normal distribution. Correct? Now the question arises, can we approximate Poisson distribution? If yes, then what are the conditions? And how can we approximate Poisson distribution? With what sort of distribution we can approximate it? Okay? Today's video is all about the same. But before we start, a small request. After watching the video, if you find it useful, then please like the video. Help your friends and other students who also are in need of such useful content by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. So let's begin with today's video now. Today we are going to see how normal distribution can be used as an approximation to Poisson distribution. Now to understand this, what we will see is, we will see the probability distribution curve of a discrete random variable which is following a Poisson distribution. Okay? So here if you see, I have drawn a probability distribution curve for a discrete random variable x following a Poisson distribution, okay, having a parameter lambda equal to 1. What is lambda? The average rate of occurrence of this particular random variable. Correct? So this x, when it takes different values, like x is taking a value equal to 0, x is taking a value equal to 1, and so on. Okay, we have plotted the probabilities, the corresponding probabilities. So if you see the probability towers, okay, the tower height goes on decreasing to the right. Okay, it has, this particular distribution has got a long tail to its right when lambda is equal to 1. Now let's see, if we increase the lambda, what happens? If I make lambda equal to 2, then we see that to the left of this tall towers here, there is also a tower, okay, which is of an increased height. Okay, initially for lambda equal to 1, there was no tower to the highest tower to the left of it. But here we have got now one tower, one for x is equal to 0. Okay, we have got a value which is of a particular value here, p equal to greater than 0.1 it is. Okay, now if I increase lambda, what happens? Further increase this lambda. So if I increase this lambda, you see the probability distribution curve starts becoming more and more symmetrical. This distribution curve becomes more and more symmetrical. For x is equal to lambda equal to 3 and for lambda equal to 5. If you see, for lambda equal to 5, it is becoming more and more symmetrical. It is becoming centered about this particular 4 and 5 here. Okay, the taller tower. So if I increase lambda further, let's see what happens. Here I have made lambda equal to 10. So if lambda is equal to 10, okay, the curve becomes more and more symmetrical and becomes more and more concentrated. Okay, it becomes more and more symmetrical on either side of these tall pillars here. So till what we can increase lambda so that it becomes more and more symmetrical? Let's try to see. Here I have taken lambda equal to 15. If we take lambda equal to 15, the curve is becoming again symmetrical, correct? It is taking a shape of a bell curve. So can we say, is it safe that when lambda is greater than 15 or more than 15, then we can approximate this particular binomial distribution using a normal distribution. Why? Because if you see a normal distribution curve, the normal distribution curve is also a bell-shaped curve, correct? So we can very easily say that if lambda is greater than 15, then the Poisson distribution can be approximated by a normal distribution. But for Poisson distribution, the parameter is lambda. The mean as well as the variance both are equal to lambda. So that means for approximation of Poisson distribution using the normal distribution, the mean will be also equal to lambda and the variance also will be equal to lambda. Correct? So the same thing can be written down in the form of a condition. We can say that when lambda is greater than 15, then a discrete random variable which is following a Poisson distribution, it can be approximated by a normal distribution where the mean and the variance both are equal to lambda. Correct? But we need to be really cautious here. What we are trying to do is we are trying to do an approximation of a discrete random variable using a continuous random variable. You might have studied in stats 1 that whenever we do such a thing, that is approximation of a discrete random variable using a continuous random variable, we will have to do a continuity correction. Okay? So here also we will have to apply a continuity correction of add 0.5 or subtract 0.5 depending upon the scenario of the question. Why we are doing this? Because we are approximating a discrete distribution with the help of a continuous distribution. In the next video, we will take examples on this particular concept to understand the same more clearly. Okay? That's it for this particular video. Hope you have enjoyed this video. If you have found this particular video useful, then please like the video. Help your friends and other students who also are in need of such useful contents by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on the channel. Comment what was good and what can be improved. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.